Hey guys, in this video we're going to talk about types of discontinuities. And there's 4 different types that we're going to talk about, so let's get started. So the first one over here, this is a removable discontinuity, and I'm going to explain what this means in a second. So removable discontinuity. So as you can see in this graph, or this function, we have a hole. So this is the first criteria for a function, or a function to have a removable discontinuity. It has to have a hole, and the left-handed limit must equal the right-handed limit. So as I'm approaching, let's make this value, I don't know, x equals 5. So the limit as x approaches 5 from the left-handed side for, let's say, call this function f of x, for f of x must equal the limit as x approaches 5 from the right-handed side for this function f of x. So let's test that. So if I had, if I was going from the negative side on this function, I reach this value, let's make this 2.5, and then if I come from the right-handed side, I get closer and closer to x equals 5, and I see that my y values are approaching 2.5 as well. So I know that the limit exists, and we have a hole, so therefore it has to be a removable discontinuity. Let's move on to our second type. This is an infinite discontinuity. And this is true when the left-handed side never touches the right-handed side. Handed side never touches the right-handed side. So let's look at this example over here. This is 1 over f of x equals 1 over x. So we see the left-handed side of this function, which is over here, is never going to touch the right-handed side of this function because of the asymptote. Therefore, this is an infinite discontinuity. The third type, and this is my favorite and the easiest to distinguish, is called a jump discontinuity. And this is called jump discontinuity because the point literally jumps from the left-handed side to the right-handed side. There's no connection. So the limit doesn't exist, and you have a hole in the graph. So let's see. Let's write this. So the limit as, and let's call this x equals 1 over here. Limit as x approaches 1 from the left-handed side does not equal limit as x approaches 1 from the right-handed side. The thing that, differentiates the jump discontinuity between the infinite discontinuity is that, they're not touching, but it's not because of an asymptote. For an infinite discontinuity, you need to have these asymptotes. And then the difference between a jump discontinuity and a removable discontinuity is the fact that the left-handed limit equals the right-handed limit in a removable discontinuity, but in a jump discontinuity, the left-handed limit, doesn't matter, left-handed limit does not equal the right-handed limit. That's our biggest differentiators. Our last type is going to be called oscillation. So this is an oscillation. Oscillating graph, oscillation. And this is a type of discontinuity. And this function over here, I tried my best to draw it, is y equals sine 1 over x. This is a discontinuity because a limit does not exist here. The points are bouncing, between -1 and 1, like -1 and 1. It's going from 1, negative 1, 1, negative 1, 1, negative 1. They just keep going. The closer and closer you try to get to 0, the points just keep bouncing. We never find out what that value is. So therefore, the limit does not exist. So limit as x approaches 0 for sine of 1 over x equals dne, or does not exist. The differentiator between oscillation and jump discontinuity is that, yes, the points are jumping from 1 to negative 1, but they're also jumping back to that same point. So it's going 1, negative 1, 1, negative 1. Whereas in jump discontinuity, it's just going from 1, negative 1, and that's it. It's just jumping and moving on with that function. Whereas here, you see it's the same function, and you're going back and forth between the y values. Fun fact, a jump discontinuity can be represented through a piecewise function. So yeah, these are our 4 types of discontinuities: removable, infinite, jump, and oscillation.